All right, and we're live. Hey, everybody, thanks for joining me for our webcast, which is going to be an introduction to Node.js, aimed specifically towards you guys on the full stack Nanodegree, because we get a lot of requests for Node.js since it's so popular now. So what I'm going to do kind of to make learning it easier is also give comparisons to Python along the way, since that's what most of y'all are probably most familiar with. But anyway, I am Ty. I'm a course manager here at Udacity on the full stack Nanodegree team, and also a full stack web developer myself. As always with our webcasts, feel free to ask questions using the little Q&A feature. I think it should be on the left, if I'm not mistaken. I will try to get to those questions at the end. So let's jump right into it. So for those that don't know, Node.js is a runtime environment, which is based on Google Chrome's V8 JavaScript engine. And what it does is it allows you to write JavaScript on the server side. It's a common misconception to call Node.js a programming language. JavaScript itself is the programming language. They share the same syntax, and most of the APIs and libraries are the same. But Node.js itself is a runtime environment, and basically it lets you write JavaScript on the server and exposes some additional APIs that you normally wouldn't have access to. For example, you can work with files directly from the computer, which is something you can't do with JavaScript in the browser. So some of the benefits of writing Node in this day and age include being able to write the same language on both the client side and the server side, JavaScript, like I just said. So that's awesome, if you've got a small development team, especially because you don't need to have people well-versed in more than one language. It is event-driven and asynchronous. And what that means is that your applications, instead of just executing things kind of in order, like a language like Python, it can be a little more alive in the sense that it'll respond to events and kind of call functions when necessary. That way you don't have to do something like, let's say you make a call to some API and it's going to take a while for it to return. You don't have to wait until that comes back before you can move on to the next thing. And I'll get more into events and asynchronous programming later, since that'll be very new for Python developers. It has what's called non-blocking I/O. And what that means is that despite being a single-threaded language, unlike Python, which lets you have multiple threads, so you can do things concurrently, normally that would be a huge disadvantage. But because Node.js is non-blocking, you don't have to wait for something to finish before you move on to other function calls, things like that. And what is perhaps the biggest benefit beyond being able to write the same language on the client and server is the huge and growing community that Node has. It's very large right now, continues to grow. And that means you can always get help and support online. And Node has a great ecosystem in general through its package manager, NPM, which I'm going to get into a bit later. But before we talk about any of that, let's just dive into kind of the basic syntax of Node.js. AKA JavaScript for the most part. So this is especially meant for those of you that have never really looked at JavaScript before. So nothing too exciting if you've worked with JavaScript a lot, but what I'm going to do is share my screen with you real quick and take a look at some examples. So let's dive right in. So the first example is quite simple. Hopefully you guys can see that all right. I can make it a little bigger. And this is kind of the classic hello world example that we always want to start with. In Python, you would say print hello world. In this case, it's console.log, which is exactly the same thing. So if I run this, hello world, and the undefined you see there just means that it didn't return anything. So that's it for that example. Nothing too exciting or confusing, hopefully. Next, what I want to go on to is talking about variables and types. Also, kind of pretty basic. So from the top here, just like Python and unlike languages like Java or let's say C++, Node.js is a dynamically typed language. And what that means, essentially is that you use the var keyword to kind of define anything. You don't need to say, like, if you want an integer, you don't say int x equals 0 or double or Boolean or anything like that. JavaScript and Python as well obviously still have types, but it's up to the interpreter to kind of figure out what those are. there are no explicitly defined types. So if we just go through this, these are all number types. So we have x, which is an integer, 0. We have y, which is a floating point. You actually have an infinity keyword here, which is essentially just bigger than any other number. So useful in some cases where you're comparing things. You can actually write using bases other than 10. So we have octal right here, which is base 8. So that's the number 15. And then we have binary right here. So you just prefix it with 0 and then O for octal and B for binary. So pretty nice. You also have not a number, which would be something like 0 over 0. That would evaluate to not a number rather than giving you an error. And then JavaScript and Node.js as well. All implementations of JavaScript have the math library, which is exposed by default. You don't need to import it. And you can say like log of 10 right here. So it has a bunch of useful and commonly used constants and functions and things like that. So that's numbers. Those are all the kinds of numbers you can have. We also have strings. So that's me right there. One thing to note is that single and double quotes doesn't matter. Use whatever you prefer, or whatever is most convenient for whatever the content of the string is. So you can have like a single character like that. Again, doesn't matter that I use single quotes. Just like 99% of languages, we can use the backslash to escape things. So \n, just like Python, is a new line. You can also have an empty string. So that's strings. Booleans are also pretty straightforward. We have true and false, go figure. And you can also do things like have a comparison and then save its result to a variable. So last I checked, 0 does not equal 2. If it does, let me know so I can be confused about why math is broken. So 0 equals 2 evaluates to false. And we're going to set that to x. So x equals false right there. This is where JavaScript gets a bit messy. We have both the null and undefined types. And those are very similar, but also distinct types. So if I just declare a variable right here without assigning anything, it's just undefined because, again, go figure, the variable isn't defined. So that makes sense. I can also explicitly define something as undefined. There is almost no use case for that, but it's something that's possible. So I wanted to just show you that you can do it. You can define something to null, which, as you can see in my comments below it, is, again, not the same thing as undefined, even though they would both kind of mean nothing generally. The main reason they both exist is because they just have different internal meanings inside JavaScript itself. But generally, if you wanted to define a variable that has no meaning or no value, you would use null. You would never really set something to undefined. And then we have the type object. So if you're familiar with other object-oriented programming languages like Java or Ruby, basically like everything that's not a primitive type like Boolean or number is an object at the end of the day. And in JavaScript, even a function is an object. That's something we won't get into. Feel free to take our object-oriented JavaScript course to get all like the gritty details about how that works. But this is an object, and if you're familiar with Python, which some of you probably are, most of you actually, it's basically a dictionary. So this is an empty object, no keys, no values. This object has a bunch of keys and values in it. Unlike Python, I do not need to have quotes around the key, which is kind of nice. The less code you have to write, the better. And I think it's just kind of like cleaner to look at in JavaScript. And that object doesn't have to have a particular type. You can put anything inside of it, including other objects, arrays, whatever you want. Objects are super useful. So that's it for that example. So next, I want to talk about doing some basic arithmetic, just so you can see all those operators. Again, you can all have a collective yawn right now because this is very, very similar to Python and every other language on Earth. So right here, some basic math. 4 divided by 2 is, wait for it, 2. So if I were to log that variable, it just prints out the number 2. You can do more than one operation at a time. I'll just kind of go through this quickly since it's nothing really exciting. Parentheses, so you preserve order of operations and things like that. 3 divided by 0, that evaluates to infinity. You might say, like, hey, how come that's not a number? The shorter answer is because the developers of JavaScript decided to make it that. The longer answer is that you can actually look into the way that floating point numbers are implemented on the computer. Look up IEEE floating point, and you can get like a really nice detailed explanation as to why something like 3 divided by 0 evaluates to infinity. We can do more floating point calculations. So 3 divided by 2 is 1.5. We have modulo for getting the remainder of things. And again, we have this math library, which is, again, included by default. And I could round down to 2. So if I run that, you get a bunch of numbers that print out. Again, nothing too exciting there. So on to the next one, which is loops. So this is all going to look pretty straightforward, a little different from Python, but pretty readable regardless, and especially if you're familiar with languages like Java, C, or most kind of C-like languages. So we have a for loop, which has 3 parts to it. The initial value, and you can declare the variable right inside of here, or I could use an existing defined one. So we have the initialization, where it's going to max out. So once it gets to 9, the loop is going to exit, and then the increment, in this case plus plus, it's just going to increment by 1. And then when I run it later, you'll see what gets printed out, which is going to be 0 to 9, as you might imagine. I can reuse I here and just reassign it to 3. We're going to stop when it equals 81 and just multiply I by 3 each time. So that's a basic for loop. For iterating over objects, we have this convenient for in loop. So I've made an object here with a bunch of different keys and values. And what I can say is for each key inside of that object, give me the key name, and then I can access the actual value by saying object key inside the square brackets. Normally in JavaScript, you can use this kind of neat dot syntax for objects. So I could say object dot like list of things, or I could just do this instead. This is like what you would have to do in Python normally. But in the context of the for loop, I can't just say object dot key, because then it would look for the actual key that's called key. So you have to use the square bracket syntax inside of a for loop, but pretty similar to Python regardless. We have while loops. This while loop will just exit immediately because, again, last time I did some math, 0 did not equal 2. Again, let me know if it changed. Hopefully not. While loops, here's a more useful one. This is just going to print out every value of x from 0 to 9 because you stopped when it is right under 10. And then we also have a do while loop, which is essentially the same, except that it's going to get the stuff inside of the do portion is going to get executed at least once, and then the condition gets checked after. So in this case, even though 3 does not equal 5, this is going to happen once. So those are loops, again, pretty straightforward. Second to last, we have functions, very important in any programming language. So the first thing you need to know about functions is that you have 2 ways to define them. You can define them as a variable using that var keyword we saw before. Anytime you declare a function, you're given access to this keyword called arguments, which, as you might expect, gives you all of the arguments to the function. So JavaScript is a very free language. It doesn't really force you to do anything, and it's not going to really, watch your back for you. So if I define a function that doesn't take any arguments, like this one, it's not going to yell at me if I pass in arguments to it. Basically, I'll get access to all of them through this arguments keyword. So it's kind of on you and the people using your code to use the functions you define correctly. So that's why documentation is important, as always. So since JavaScript is not going to watch your back. and yell at you if you pass in too many arguments, not enough, or maybe arguments of the wrong type. So that's how you define a function and call it with the var keyword. So pretty straightforward. The second way is to use the function keyword, and I'll get on to like what's different about them in a second. But right now, pretty much the same way. We have the return keyword just like in Python, and this function is pretty straightforward. It just adds two things. And here's where dynamic typing comes into play. Even though you might expect that people are going to pass in numbers to an add function, I can pass in strings too, and it'll just concatenate them. So no issues there. And now on to the difference. There is really only one difference you need to care about, and that is that when you define something with the function keyword, it gets evaluated at parse time. So what that means is that I can call a function that's defined using this keyword before I actually define it in the code, because when the interpreter goes through and reads through your code to check for things the first time, it's going to add this to the global scope, or whatever scope you define it inside of. And what that means is that I can call it anywhere. It's available to you. Whereas if you use the var keyword, that's not the same, and this will give you an error saying this won't work, is not defined. So if I actually run this, scroll up, we get all the normal stuff. So here's where I printed out the contents of that arguments object. And then yippee, because this function worked. And uh-oh, we get an error because, just like I said, you cannot call a function defined with the var keyword before you actually define it. So last, what I want to move on to is importing and using packages and libraries, which is very important. Here's a pretty example. Whereas in Python you would say import XYZ, we have the require keyword in Node.js. So query string is actually a module that's part of the language that you can import. Just like sys for system in Python, it's provided for you, part of the standard library. And what this lets you do is parse query parameters. One of the big appeals of Node.js is its ease of use for web development. So that's why a module like this is included just in the standard library. So I import it as QS. I could call it anything else. And it has a parse function that's going to turn this into an object, so I can actually see, foo equals 0, and it'll give it like key value pairs. So if I click run, we get this. So it turns that string into this. So that's kind of like a basic example of using modules. So I'm going to stop sharing my screen for now and get back to some more stuff about Node. Again, just a reminder, feel free to ask questions using the Q&A feature at any point, and I'll get to them at the end. So one of the big appeals of Node.js, like I was saying, is the community. And what comes with that is a great ecosystem. And what I mean by ecosystem is kind of the tools and things like that that are available as part of the language. So that includes NPM, which is Node.js's package manager. It's kind of like pip or easy install for Python, more like pip than easy install. What's really, really nice about NPM, this is the biggest benefit, and I wish more languages had this, is that you can install both global packages that are system-wide, which is all you can do with Python if you don't use virtual environments. So I can use, if I were to type npm install and then put the -g flag before the package name, it'll install it globally. So like a common use case for installing something globally is like a command line tool. And then you can also install local packages, which are basically packages that only work with the project they're installed for. So that's what's most useful about that, is that let's say you had two projects on your computer. They both require the same package, but different versions. If this were Python, you would need to use virtual environments for that to work, because you can't install, at least to my knowledge, I don't know if that's changed recently, but you cannot install two versions of, let's say, like the requests library. You're just going to have the global one, and it's going to be the latest version usually. But with NPM, because you have global and local scopes for installing things, you can have a billion versions of the same package on your computer. So that's really, really nice. A little side note for those of you that keep up with like kind of the development world in software news. NPMs had kind of a rough couple of weeks. There was a big story that went out. You might have seen it on like Twitter or Hacker News or something. Some developer had this very small package. It was called LeftPad, I believe. And basically it was like 10 or 15 lines of code that he packaged as a module and published it that would just pad a string that you pass in by like 10 spaces. So it would just basically like move it over a bit. Not the most useful thing on earth. Definitely something you shouldn't install as a module because it's so easy to do yourself. But basically what he did was remove that package from NPM, and it actually broke a bunch of kind of big projects in the Node community. So always, it's kind of a good lesson. Only install a dependency if, one, you need it, and you know you need it, as in like it's not worth implementing yourself, and you're sure that it's going to be maintained in the near to medium future. You don't want to just install some like random thing that people have downloaded 3 times and hasn't been updated in a year. So make sure you're using like high quality, well-maintained packages. So that's NPM, which is like the most important part of the ecosystem, because it lets users contribute to Node and add a bunch of great libraries. There's also the REPL, or read eval print loop, and that is that's the actual Node command you'll run at the command line, just like typing Python, and it'll give you that interactive development environment where you can type a line, hit enter, see the output. So it's really nice. There is also version management tools available. So this isn't something that's super popular in the Python community. You have Python 2 and Python 3, and most people have both installed on their computer. But with languages like Node and Ruby, it's very common to have like a bunch of versions installed on your computer at the same time. And this is not something you can do by default just by installing Node from, let's say, like just the main website. But you can use version managers to basically let you have, let's say, like Node version 0.10 and 5.0 and 4.0 all on your computer at the same time. And then you can just switch between those to like set a default. So again, that's really nice if like you have 2 projects on your computer that depend on different versions of Node.js. For those familiar with Ruby, you may have heard of like RVM and RBN. Those are 2 of the most popular. In the Node world, the 2 you'll see are NVM, which stands for Node Version Manager, and just N. And I haven't mentioned it yet, but after this webcast, I'll be uploading it to YouTube and writing a big summary on the forums. So there'll be lots of helpful links to all of like the tools and things like that I've been mentioning. So don't feel a need to write these down or keep it all in your brain. So that's the version management capabilities. There are also a lot of popular modules I want to mention, and again, I'll link to these. One is Express, which is the most popular web server for Node. It's kind of similar to Flask with Python. Very lightweight, very simple to use, and quite extensible. You can write your own kind of modules that are meant to work with it. There is Request, which is an HTTP client. Some of you may be familiar with Python's requests with an S library. It's basically the same thing. There is Async, which is tools for working with asynchronous function calls, which will make sense in about 2 minutes when I get to that. There's Passport, which is a popular authentication library, so you can have like OAuth with like Google, Facebook, Twitter, things like that. There's Underscore, which is, and Lodash, which are 2 very popular just utility libraries. There's Gulp and Grunt, which are build tools. PM2, which is a really awesome process manager. And my personal favorite, which is a library called Chalk, which lets you print out strings with fancy colors. So again, I'll be writing all of these down. That probably went too quickly to remember all of them and what they do. And again, the biggest thing with any language is the community, and Node has a great one. It is growing, and you can find plenty of tutorials and help online for anything you need. Part of that is just because JavaScript's the de facto language of the web, so you have access to all of that documentation that already existed before Node 2, such as like the Mozilla Developer Network and things like that, Microsoft's as well. So that's it for the kind of community and Node ecosystem. The last thing I want to touch on before I let you guys go is a brief intro to asynchronous programming. And we're going to learn that through 2 things. One is events, and the second one is callback functions. So we're going to dive into that through some code examples. So I will share my screen with you once more and take a look at some code. Let me just find it. Too many windows open. There we go. Hopefully you guys can see that. So let's talk about async. So, like I said, most languages are synchronous, Python being one. You write your code and things get executed in order, and unless you're using threads, you don't move on to the next thing until the previous command is finished. So that, like, an annoying example of that would be, let's say you're not using threads. So you make a call to like connect to a database, and then right after that, you just make a call to assign a variable to something. If connecting to that database takes like 5 minutes, it's going to be 5 minutes before you can move on to assigning that variable. So Node doesn't have that issue because of its asynchronous nature. So the first thing I want to chat about is events. And think of an event as like a signal that gets sent out when something you care about happens. So let's say you have a web server. It's going to emit like the connection event every time a new client connects to it. And then you can set up something to respond to that connection event. So you can do whatever you need to with that. So that's really, really useful. And it just kind of goes well with the like asynchronous nature of the web. Things don't just happen in a set order in a web application. You might have like a web app, and then you want to respond to something when a user clicks on a button or they submit a form, things like that. So once you start doing a lot of web programming with Node, you'll definitely like really see the benefits immediately. The common example I just gave you is in the browser, there's this click event that gets sent out every single time you click on a button, and then you can set up a function to respond to that, like, as simple as like logging to the console, or maybe you're keeping statistics on your web app and you want to be able to like, keep track of how many people have clicked on this button, something like that. So very, very helpful. So if we want to work with events from Node, there are tons of ways to do it. You have this events library, which is part of the standard library. So we're going to set that to a variable called event emitter. We're just importing it. Create a new event emitter. So that's a keyword you guys haven't seen, this new keyword, which creates a new instance of this object. So to respond to events, we need to do what's called listen to them. So we set up, go figure, a listener. And that does exactly what it sounds like. It listens for this event to happen and allows you to respond to it. So I'll just set this variable x to 0. And here's the listener right here. So we have our event emitter object. And when the event add1, which is an event I just made up, there are no like default ones you have to use. You can call them anything. When this add1 event gets emitted, we're going to just increment x by 1. So right now, were I to print out the value of x at this point in the code, it's still 0. So I'm going to emit the add1 event twice. And because we set up this listener, x is going to get incremented twice. And then I'm going to also emit this event that I called nope. And nothing's going to happen just because we haven't set up a listener to respond to it. So were I to log x at this point, I would get 2. And just to prove that I'm not lying to you guys, I'll run it. And this will be the last piece of code we see. So there you go. Initially, x is 2. After the event gets emitted twice, initially x is 0, sorry. And once the event gets emitted twice, x equals 2. So that's kind of a very basic example. Again, I'll be posting on the forums and provide links and helpful tutorials to learn more about working with events. So that's it, guys. I'm going to stop the screen sharing. And now on to the questions. So first we have Node has a framework. I'm actually not too sure what you mean by that. I'm not sure if you're talking about like NPM, which is the package manager for Node. You can write libraries for Node.js, like Express is a web framework that I mentioned. Or maybe you're referencing the fact that Node.js is itself not a programming language, but instead a runtime environment that lets you write JavaScript on the server. I can delve into all of that more in the forum post in case that didn't really clear up anything for you. Question number 2 is, what can chalk do for me? And chalk is that string library I mentioned. So it's not the most useful thing on earth, but it lets you kind of add colors to your strings. So when you print things out on the terminal, you can get nice colored output. So it's useful for like logging things to make things more readable. But it was kind of just a fun library I mentioned at the end, definitely not necessary. So here's a bigger question. I've heard that there are good performance reasons for choosing Node, especially when scaling. Can you describe what some of these factors might be? Yeah, absolutely. So Node is very scalable because of its asynchronous event-driven nature, which I talked about a bit, and I can delve into performance more and the benefits of Node in the forum post. But the biggest reason is that you can have a million things going on concurrently at once. Your web server is not going to get hung up by one API call or a function call that's just taking forever. So because things run concurrently, even though it's only single-threaded, that's why it's very scalable. I can have a billion people connect to the web server at once, and that all gets handled at the same time. I can make some call to a database that could take a year to return, and it doesn't matter. It's not going to block the rest of my program from executing anything. So again, I'll delve into more detail on that, but hopefully that cleared it up. And I think that's it for the questions. So speak now or forever hold your peace if you have any more questions. I'll wait about another minute before I end the webcast. And be sure to check discussions.udacity.com under the full stack Nanodegree broadcast section for the forum post, kind of summarizing this webcast. All right, looks like that's it. If anyone's trying to get a question in right now, don't worry. Feel free to ask on the forums, and I'll get to it. So that's it for the Node.js webcast, guys. Feel free to message me on Slack if you're in the Slack community. I am at TyLucasKelly. You'll notice that I just posted in the general channel about the webcast. So feel free to message me anytime if you have questions. And we're always taking suggestions for more webcasts. Maybe I'll follow this one up with like a more advanced tutorial on Node.js and actually like going through and writing a web server. But anyway, keep an eye out on the forums, and thanks for joining me, guys. Bye-bye.